Hi, welcome to this video on t-tests for differences in means. This is the first part in a two-part video. You may remember t-tests when you were in your previous stats class, but this is a fresh reminder of most importantly why we use this. We will learn how to calculate t-tests and how to do them in Excel using real sample data. But on this video, these two videos, I want to remind you why we use t-tests and how to interpret the results of t-tests. Alright, so the first is, of course, the main question is when do we use t-tests? Why do we use them? So we use them when we want to know if there is a difference in means between two groups in the population. Right? Remember that we use hypothesis tests to make sure that the results we observe in the sample are not just a result of sampling error. Right. Let me explain this with an example. Suppose that we take a random sample of male and female CHHS students and ask them about their GPA. Now suppose that our results show the following, right? That male students, this is the average GPA for the male students, 2.5, and this is the average GPA for the female students in our sample, it's 3.5. As you can see in this sample, female students have a much higher GPA than male students on average. So that is a big sample result. Now, though, is this result also taking place in the population? Do female students have higher GPA than male students in the population? We know that's happening in the sample, but is that happening in the population as well? We don't really know, right? Because when we take a sample, we are likely to have sampling error, right? So did we just happen to obtain a sample of really good female students and not so good male students by chance? Remember that this is a random sample, right? So by chance we can pretty much get any type of composition because of sampling error, just by chance. So the t-test would allow us to rule out the possibility that what we're observing in the sample is just the result of chance, or is just the result of sampling error, right? So that's why we do a t-test. These are the steps in the t-test. We'll be discussing each of them in the following slides. The first one is to determine the appropriate t-test that you need to use, and that is a function of the type of sample you're dealing with, or groups that you're dealing with. And these ones should be more familiar to you because they are steps that pretty much have to be taken in any type of hypothesis test you do. So let's start discussing them each one by one. First, to determine which t-test to use, you have to ask yourself if the samples are matched. If the answer is yes, then it's straightforward. You use a type 1 t-test, right? And we will discuss what this means in the next slide. But if the samples are not matched, then you have one more question to ask yourself. Are the variances for each of the groups equal in the population? Right? Are the variances for this interval level variable that we're interested in, does it vary between groups? Right? Using our example, this would mean that the variance of GPA is not equal to for males than the variance of GPA for females in the population, right? If we have a reason to believe that that they are equal, right, in the population across men and male and female students, then we use a type 2 test, right? It's a non-paired samples assuming equal variances. But if we have a reason to believe that the variances are not equal for these two groups, we will use a type 3 t-test, which are non-paired samples assuming unequal variances. Now, how to determine if the samples are matched? We say that they are matched or paired when each observation in one sample is paired with an observation in the other sample. Right? So the most common case of matched samples are pre and post tests. Right? Under that research design, we have two samples, but they correspond to the same individual, right? Same group of individuals, and they are matched, right? So we observe a group of people at one point in time. That's one sample, and then we observe the same group of people at another time on the post test. And we have observation for the same individual at 2 points in time, and we can pair those observations, right? When we can do that, we have a paired sample, or we have matched sample, right? Now, in some cases, especially when you're using surveys, you may have the same survey distributed to the same group of people, but you may not be able to match the observations on the pre to the post. In that case, if you cannot match them, then you don't have matched or paired sample, right? Only when you have the same, when you have the individuals in one sample that can be matched with individuals in the other sample, you can use a matched sample or paired sample t-test. If not, then you don't have a matched sample t-test. Then if you determine that the samples are not matched or paired, you have to ask yourself, do we know if the variance in the population for one of the groups is equal to the variance of the population in the other group, right? And if they are, then you would assume that they have equal variances. If they're not, then you would use another type of test, a type 3 test. Now, there are tests that can be used to see if the variances are equal in the population or not. We're not going to cover them in this course. They are F tests. We're not going to cover them again. And many researchers, even when they can do F tests, they prefer to perform 2 tests, right? They first assume that they have equal variances in the population, the 2 groups, and they assume that they don't have unequal variances in the population. They do the 2 tests, they get the 2 results and present both and let the reader decide. I like this approach, right? And especially since computing t-tests, is using computers it's really simple. So there's not much work added to computing both tests. So for the purpose of this course, we want you to report results of t-tests assuming equal variances and assuming unequal variances. Okay, so down to what I think is the most important step in a hypothesis test, stating the null and the alternative hypothesis. Let me correct this typo first. All right, so the null for a t-test for difference in means is that the mean for group 1 is equal to the mean of group 2, right? So the means for group 1 and group 2 are equal in the population, right? Remember that hypothesis tests are about the population, so our null is we're stating something about the population, and we're saying that the means for group 1 and group 2 are equal in the population. That's our null, and this is always the null in a t-test for differences in means. The alternative hypothesis that we'll be using is a non-directional alternative, right? This means that we're just going to have one alternative, that the means for group 1 and group 2 are different in the population. Right? So the null is that the means for group 1 and group 2 are equal, and the alternative is that the means are different or not equal in the population. So if we reject this, we accept this. If we reject the null, we accept the alternative, that they are different. Now, you may remember from past stats courses that they are directional alternative hypothesis, right? We could also say that the mean for group 1 is larger than the mean for group 2 in the population, or that the mean for group 1 is smaller than the mean for group 2 in the population. Now, I'm not a big fan of directional alternative hypotheses, right, as they should be used only when there is a strong theoretical justification for doing so, right? And they're less conservative. So for the purpose of this course, we will be using the more conservative non-directional two-tail alternative, right? We will have one null, it is always a null, and one alternative. The means for group 1 and group 2 are different in the population. Step 3 is determining the sampling distribution of the t-statistic when the null hypothesis is true. This, in other words, is finding the degrees of freedom for your test. And the degrees of freedom depend on the type of test you're using. When you're using a paired sample t-test, the degrees of freedom are given by n minus 1, and where n is the sample size for that for the sample that is matched, right, to another sample. For a type 2 non-paired samples with equal variances, the degrees of freedom are given by the sum of the sample size for group 1 plus the sample size of group 2 minus 2. And for paired samples, t-test with assuming unequal variances, the degrees of freedom will be given by the smaller of these two quantities. So you would calculate the sample size for the first group minus 1, and you would also calculate the sample size for group 2 minus 1, and you would pick the smaller of the two, and that would be that will give you your degrees of freedom. Now, this is the conservative way of calculating the degrees of freedom, and in this case conservative is good, but just in this case. After you choose your degrees of freedom, you would choose your significance level for your test, right? Now, you would remember this from past stats courses when you did hypothesis testing, that the significance level is the probability that you will incorrectly reject the null hypothesis, right? In other words, that you would end up concluding that the means are different in the population when they are in fact not. You decide on this probability that you want to give yourself of committing this error, which is, by the way, a type 1 error. In statistical books, the significance level is referred to as alpha, and by convention, in social science, we give ourselves 5% at the most, right? That is, that we will give ourselves only 5% chance of incorrectly rejecting the null. But in some cases, researchers, especially when you're dealing with large samples, would not consider anything above 1%. Right? They would not. They would only give themselves at the most 1% chance of incorrectly rejecting the null. As I already stated here, when you choose an alpha of 0.05, right, that means that you're giving yourself at most 5% chance of incorrectly concluding that there is a difference in means in the population when there is none, right? Now, why do we do this? Why do we choose significance level and the degrees of freedom? Well, in practical terms, because we want to find the critical value for our test, right? The t critical value for our test. And so we would do that with the degrees of freedom that we have and the alpha that we have, right? If you pick an alpha of 5%, right, you would choose this column, right? And then, depending on the degrees of freedom for your test, you would pick a row, right? And where these two intersect, that's your critical value for the test, right? Now, once you have this, you are ready to calculate the t-statistic for your test and see if you can reject that null. But this is the end of part 1. In part 2 we will see how we do that.